So let's go ahead and take a look at an example here with real numbers and figure out what we need to do. Now, the number of cells, starting with 4, so my initial amount is 4, triples every 6.3 hours. A total of 2,500 cells are needed to run a particular experiment. How long will it take before the experiment can be run? So I start off with 4 cells. I know it triples every 6.3 hours, and I need to figure out how long it would take to get a total of 2,500 cells. I'm growing these cells. So I know that it triples. So 3 equals e to the kt. But I know that happens every 6.3 hours. So that tells me that 3 is equal to e to the k times 6.3. So with this, I can actually solve for k because I know t. Once I solve for k, I can actually come up with a model that will model the growth for this specific situation or this specific scenario. So I'm going to solve just like I did earlier, only this time I'm going to solve for k rather than t. So I have ln 3 equals, if I take the log of both sides, I'll get 6.3k. That implies that k is equal to ln 3 over 6.3. Now notice that ln 3 and 6.3 are both positive. So I know that k is going to be a positive number. This is the exact answer. If I'm going to put this in the calculator, I may stay with this and then approximate later. But the approximation for it is 0.1744. So it's approximately 0.1744. So now what I want to do is, now that I have k, I know that, let's just call it f of t, is going to equal my initial amount, 4, times e to the 0.1744 t. And I'm going to write it in exact form here as ln 3 over 6.3 t. Now this is going to be a little bit more exact, but honestly it may only make a difference out here, or maybe one more decimal, so they're going to be awfully close. Now the point here is, the question is how long does it take before I have 2,500 cells? So I need to set this equal to 2,500. So I need to solve my model, 4e to the ln 3 over 6.3 t. When is this going to be equal to 2,500? Well, start off solving it like you would any other problem. I divide by 4. I will have e to the ln 3 over 6.3 t equals 2,500 divided by 4. Now if I take the log of both sides, I end up with ln 3 over 6.3 t equals the natural log, yeah, that's right, ln of 2,500 over 4. Obviously, when I took the log of both sides, I had ln e, which is 1, so I didn't even bother writing that. That would then tell me that the time it's going to take, t, is going to be ln of 2,500 over 4, so natural log of all that, divided by ln of 3 over 6.3. Now again, this is an exact answer. So what I really need to do is put this into a calculator and approximate it. And when I do that, I get that t is approximately 36.9173 hours. So it's going to take about roughly 37 hours before we can actually run this experiment. Now, just as a side note, when I also calculated this using the 0.1744 approximation for ln 3 in here, out to 4 places, I did in fact get the same thing. I really don't recommend you do that. You should stay exact as long as you can. But if the exact form gets really complicated to work with, then you may end up tossing in an approximation. The problem with approximating early and then using that approximation to further approximate down here is you could propagate error and you could end up being off a little bit.